Welcome to our deep dive into one of the universe's most enigmatic phenomena, black holes. These cosmic abysses, shrouded in darkness yet glowing with unimaginable energy, have captivated the imaginations of scientists and stargazers alike for centuries. Today, we'll uncover some fascinating facts about these cosmic giants, peering into their shadowy depths and unraveling the mysteries they hold. Our journey will take us to the edge of the unknown, where gravity reigns supreme and the very fabric of space-time is warped beyond recognition. Prepare to be amazed as we explore the science behind black holes, from their formation to their potential impact on the cosmos. Black holes are cosmic objects that defy our everyday understanding of the universe. They are places where gravity is so strong that nothing, not even light, can escape their grasp. Imagine a place where the very laws of physics as we know them break down, where time and space themselves are distorted beyond recognition. This is the reality of a black hole, a region of space-time where the gravitational pull is so intense that it creates a boundary called the event horizon. Anything that crosses this boundary is forever trapped, destined to be consumed by the black hole's insatiable appetite. Even though we've been studying them for decades, much about black holes remains shrouded in mystery. Imagine squeezing the entire mass of the Earth into something the size of a marble. That's the kind of density we're talking about with black holes. These objects are so incredibly dense that the very fabric of space-time is warped around them, creating a gravitational pull so strong that nothing can escape. This density is born from the death throes of massive stars far larger than our own sun. When these stellar giants exhaust their nuclear fuel, they collapse under their own gravity, imploding in on themselves and creating a singularity, a point of infinite density at the heart of a black hole. Black holes come in a variety of sizes, each more mind-boggling than the last. At the smaller end of the spectrum are stellar mass black holes, formed from the collapse of individual stars. These black holes can be just a few times the mass of our sun, but they pack that mass into a region only a few miles across. Then there are the supermassive black holes, cosmic monsters that lurk at the centers of galaxies, including our own Milky Way. These behemoths can have masses millions or even billions of times greater than our sun, with event horizons spanning billions of miles. Stars may seem eternal, but even they have a life cycle. For massive stars, many times larger than our sun, this life cycle ends in a spectacular and violent way, the birth of a black hole. As a massive star nears the end of its life, it runs out of fuel in its core. This fuel is what keeps the star shining and, crucially, what counteracts the inward pull of its own gravity. Without this outward pressure, the star's core collapses in on itself, a catastrophic event that triggers a supernova, a blinding explosion that can outshine an entire galaxy. The core, however, continues to collapse, crushing itself down into a singularity, a point of infinite density. The name black hole can be a bit misleading. They're not empty spaces or holes in the fabric of space-time. Instead, they're regions where an immense amount of matter, the remnants of a collapsed star, is crammed into an incredibly small space. Think of it this way. Imagine taking a star, millions of times the mass of our sun, and squeezing it down to the size of a city. That's the kind of density we're talking about. It's this extreme density that gives black holes their incredible gravitational pull. Our galaxy, the Milky Way, is a vast and ancient place, home to hundreds of billions of stars. But it also harbors a dark secret, millions of black holes lurking unseen throughout its spiral arms. These black holes, remnants of long-dead stars, are incredibly difficult to detect. They don't emit any light of their own, so we can only infer their presence from their gravitational influence on nearby objects. Imagine a black hole passing by a star. The black hole's gravity would tug on the star, causing it to wobble slightly in its orbit. By observing these wobbles, astronomers can deduce the presence of a black hole, even though they can't see it directly. For centuries, black holes were merely theoretical constructs, mathematical curiosities predicted by Einstein's theory of general relativity. But in 2019, the world held its breath as the first ever image of a black hole was unveiled. This wasn't just an artist's impression or a computer simulation. This was a real image. captured by the Event Horizon Telescope, a global network of radio telescopes working in unison. The image showed the supermassive black hole at the heart of the galaxy, Messier 87, a behemoth 6.5 billion times the mass of our Sun, located 55 million light-years away. The image, a blurry, fiery ring, sent shockwaves through the scientific community, confirming what was once thought impossible to observe. Thank you for joining us on this journey through the cosmos, a journey to the very edge of our understanding of the universe. Black holes, once shrouded in mystery, are slowly revealing their secrets, pushing the boundaries of our knowledge and challenging us to rethink the very nature of reality. As we continue to explore these cosmic wonders, we can only imagine what other marvels await us in the vast expanse of space. The universe is full of mysteries, and each discovery brings us closer to unraveling them. Stay curious and keep exploring the wonders of our universe. There's still so much out there to discover,